Alright guys, so here's a video for 1.4, which is kind of introducing and talking about angles. Overall, I think this is a pretty straightforward day, so I don't want to waste your time. We're going to kind of go through it kind of quick. But because the lesson is a little bit on the easier side, I definitely want to take a chance to look at not just this warm-up, but also a second warm-up to make sure we are practicing and we've covered all of the really important vocabulary pieces, and then we've also practiced some of our notations and some of the nitpicks about what they mean, what you can and cannot write. So kind of like I've been doing, just feel free to pause this video and try these things out. What are the 3 undefined terms of geometry? If I have 2 distinct, this means different, lines that are not parallel, what will their intersection be? If I have planes that are different and they do intersect, what will that look like? What amount of points do I need in order to define a line? And maybe what kind of points are needed to define a plane? So answer all of those that you know, and then we'll talk about it. So pause the video in 5. So the 3 undefined terms of geometry are a point, a line, and a plane. And again, we basically were arguing that those things have no formal I can touch them definition, right? Because basically a point has no dimensions. It's just like an agreed spot that we had talked about, right? Same thing with a line and a plane. It's like an infinite line that goes on for forever. An infinite, almost like a sheet of paper or a wall would be a plane. Now, 2 distinct non-parallel lines, right? So if I have 2 lines and they do happen to cross each other, that intersection is going to be at a point. If I have 2 planes, right, it's like one sheet of paper, and then we've got another sheet of paper that's basically chopping this. It's like slicing through it, that slice through is creating a line. And if you consider the fact that these pieces of paper are technically going on for forever, that also means this line is technically going on for forever, right? And that's just that. What kind of and how many points are needed to define a line? 2. 2 points are needed to define a line. So if I have a line that says, for example, let's just call them A, B, and C, and I want to talk about what this line is, you could call it line AB. You could call it line BA. The order doesn't matter for a line. You could call it line AC or BC. But what you would not do is call that line ABC. Like, we're never going to label a line with more than 2 letters. So just all of those different options and backwards and forwards are fine as long as it has that line notation at the top to tell me it's a line. But you will never write all 3 or all 4. Heck, there's 8 points on this line. You're not going to write all 8. In fact, if you did, I would count that wrong. No credit. Okay, 2 points define a line. When we get to talking about a plane, it is 3 points that define a plane, but more specifically, they have to be non-collinear points. And here's what I mean by that. So if I took 2 points, actually, let's go with 3 points. 3 points that are all on the same line, which would be collinear. So picture like a pole that has 3 dots on it. And I say, okay, please take this giant poster board and can you lean it against the pole so that all 3 points are touching this paper? And you're gonna be like, yeah, sure. Bloop, here it is. The pole's touching at all 3 of these points. Well, another kid comes up and goes, well, what if I just take it on top? It's touching at all 3 points. Both of those students would be correct. In fact, any angle of it around the pole would be touching all 3 points. So we don't say that that defines a plane because that would be an infinite number of options. What does define a plane? Well, if I've got 2 points, that would be like the pole that we're talking about. And now if I take a 3rd point, that is just anywhere in space, like in front of the board, behind the board, under the board, like wherever I want to put it. Now, if my finger is this last point off the board, there is only one way to take a sheet of paper that touches both of those points and also angles up to touch where my hand is. There's only, if I can get this to stay sturdy, there's only one way that that will work. Okay, if I instead pick the point over here, well, now the paper has to bend this way, and there's only one place where those 2 and this 3rd point are at. So the definition of a plane requires 3 points that are not in a straight line with each other. Okay, those definitions are important. This next little warm-up I want you to look at, and I don't expect you to get all of these right your first time through, but these are just a bunch of different notations. We've talked about when it's appropriate to use the equal sign versus a congruent sign. Remember that the segment or a line or a ray, if it's got the little bar on top, if it's got some type of a hat, it is referring to the physical ink printed on the paper. And so when I say, for example, is the physical ink of AB the same thing as the physical ink from BA, I can say yes to that. But what I can't say is that the physical ink of AB is equal to the physical ink of BC, because those are not the same ink. Now their values might be equal, like they're both 5, right? So I'm just giving you a little bit of that preview. I want you to either think through these or write them all down and try them. This is definitely something I want you to see. Which ones do you feel really comfortable about and which ones not? Basically just check or X, yes you can say that, or no you can't. And all of these are referring to this diagram. So again, I'll give you a little bit of time to think about it if you'd like to pause the video. Okay, so recall, if you do not have a hat, you are talking about a distance or a value for that, okay? Anything with a hat on it is talking about the object. So, can I say that the distance from A to B is 5? Yes. Can I say that the distance from A to B plus the distance from B to C is equal to the distance of the whole thing? Yes. Can I say that the segment, the physical ink on the sheet of paper, is the number 5? They're saying, is this chunk of line the number 5? The answer to that is no. Okay, if I wanted to say that it was 5, I would say BC is 5. That I can say. The value or the distance from B to C is 5. But the second I write that segment, I'm saying the ink on the sheet of paper is the number 5. No. Okay, and I know that's silly, but you need to think about that anytime you see that hat. Okay, is the distance from A to C 10? Yes. Okay, are the segments A to B, so the physical ink on the sheet of paper and the physical ink from B to C, are they congruent, meaning are they the same size and the same shape as each other? Yes, those are the same size and shape as each other. But here, are they the same physical ink on the paper? Is this ink the same as this ink? No. Okay, and so that's sort of that difference in an equal sign is saying that they are the same thing. Congruent is that they are the same size as each other. Okay, can I say that the value or the distance from AB is equal to the value from B to C? Do those distances equal each other? Yes. Now this one's kind of interesting because we just said that the hats can't be equal to each other. They can be congruent. Well, what this one is saying is the physical ink from A to B the same physical ink from B to A? This is actually a yes, because it is the same physical ink that's going on that paper. Okay, this one says, is the ray AB the same ink as the ray BA? Now remember, they're always going to be showing the arrow pointing to the right in the way it looks, but this means that it starts at A and goes for forever towards B. Whereas this says start at B and go forever towards A. Those are different, and this is something that we would not be able to say. Is B the midpoint of AC? Yes, not just because it looks like it, because I can observe that the distances are equal. Is B considered to be between them? Yes. Okay, between just means anywhere between. Midpoint is just a special between. Are the rays from B pointing to A and the ray from B pointing to C considered opposite rays? Yes, because they share an endpoint and they are pointing in opposite directions. As well, they make a straight line. Those are the requirements to be an opposite ray. Are A, B, and C collinear, meaning are they on the same line if I were to extend this for forever? Yes. do those define a unique plane? Think of our last warm-up. What do I need? I need 3 points that are not in the same line, because if all 3 of them are, again, I could use my poster board a bunch of different ways to touch those points. So that would not define a unique plane because they have to be non-collinear. They cannot all 3 be on the same line in order to be one specific plane that we would all be able to get the same answer of. Okay, now again, that seems kind of silly, but that is crazy important. I would even recommend maybe like a day from now or before a quiz or before a test, I might even come back to this video and re-practice those one more time because that's it's a lot to think about. And I think once you get it unconfused, those answers will make sense. But at first, that's a lot to try and figure out. Okay, so now today, a lot of this I've pre-filled out, so you're welcome to pause and write down anything you want, because I think a lot of this falls into the common sense / review information from junior high, and I don't want to waste your time listening to me talk about things you might already know. So what is an angle? An angle is essentially 2 rays connected at a vertex. So if this is the vertex X, that its side is the ray with endpoint X pointing to Y and endpoint X pointing to Z. So if I gave you a random angle, let's just call it A, B, C, and I said, hey, could you label the sides of this? You would actually have to answer B to A ray and B to C ray. That would be the answers, not this one and that one. That is the formal way I would write that down, or the word and, or a comma, any of that is okay. What is the vertex? The vertex is B. It is the point B. Okay, so those are all different things that might just be vocabulary related. Here it says, when you're naming with angles, we have to use 3 letters, and the vertex will always be the second or the middle of them. So I could refer to this as YXZ. I could refer to it as angle ZXY, but it's always read in the order it says, particularly in a diagram with lots of points. I need to know exactly how to read it so I can highlight the angle at once. So again, you'll notice the order of those 3 doesn't matter. It is appropriate to call it angle X by just the vertex, but only if it is the only angle with that vertex. So what I mean by that is if this had gone and maybe these crisscross and there were other letters over here, I can no longer call that angle X because I might be talking about this one, this one, this one, or that one. There are now 4 different angles I could be talking about, so that's a no-no. However, and it is always appropriate to do this, if the problem doesn't label it like a 3, in my world, you could just write a 3 in there and you can label it as long as you have referenced it. So in a situation where I have this crisscross and I want to talk about this angle, and I can't call it X, and I'm being lazy and I don't want to call it angle YXZ, I could just call these 1, 2, 3, and 4, and now just write angle 3 to reference that specific one. So those are just different ways that are okay to label. So per this problem, label all of the correct ways or all of the correct angles that use B as a vertex. So here's B. So at a glance, there are 4 angles for that. There's this one, there's this one, there's this one, there's that one. All 4 of those are different. So you'll notice 4 different ways that I would need to write down. I'm giving you all of the alternative ways to refer to that angle, but if I told you to list, I would only need 4, and I would have taken any variation from each of these lists. So I could call that GBA, but I could also call that ABG, right? I could go in either direction. Notice that it doesn't have a label, that B is labeling the point, so I can't call that angle B. And again, referencing why I can't call it angle B is because that's not the only angle with that vertex. And that B is not a number 5, 6, 7, so I cannot just use that. Okay, but you'll notice on the other ones ABD, so A to B to D, I could call it DBA the opposite way. I could call it 7 because it has that label, right? That would be appropriate, but I still couldn't just call it angle B. Okay, and on some of these, for example, EBG, I'm just gonna re-highlight because I'm kind of losing my colors here. So E FBG, I also would have accepted FBG. That would be the same angle. There's no law that says you have to use the dot closest to it, right? Or the point closest to it. So even that would have been extra ones in the list that were appropriate. I could have called this GBE or GBF, as long as it ends up drawing that same angle opening. Random vocabulary words. The word interior angle versus exterior angle. If I pretty much, I don't want to say this is only when you're going to see it, but if I just see this angle, I guess you would call it the acute angle here, is where we are going to, no, it wouldn't just be acute. It's just the interior is sort of like the inside amount, and then the exterior would be the larger outside amount. So if I were to open this angle even more, like, so this would still be an obtuse angle, I would still call this the interior and this outer one the exterior. The only time where we wouldn't really have that vocabulary word is if those two rays are opposite rays and therefore making a straight line. There really isn't an interior or an exterior because they're both the same thing, making a straight line. So that's like the one case where we don't have it, but basically it's the smaller, like if the whole thing adds up to 360, the smaller amount is the interior, the larger amount is the exterior. There are two random postulates I don't so much need you to like memorize per se, but what they're generally saying is that the ruler postulate says that no matter what alien species you're from, there is the ability to measure lengths. Like I might call it inches, somebody else might call it centimeters, somebody else might call it a because that's what they call it on like planet Gajargo. Like, I don't know, I'm making up stuff. But the idea is a bunch of people sat around and said, yeah, no matter what we call it, there's a way to measure things. We might, if I call it 6 inches long, that may be not how you're going to talk about it because what you use as your unit is different. But it just is the idea that it is possible to always measure distances, and a protractor is used to always be able to measure angles. So they're just saying we agree that you're allowed to do that, right? So a bunch of this random stuff. If you've never used a protractor before, if we need to do that in class, I will help you with that. But basically, it's the tool that is used to help open and measure what that angle is. But again, we're just saying if you're on an alien planet where we just made up 360 goes all the way around, maybe they use 100, maybe they use 1000, right? They're going to call this a different degree, but we would all still be agreeing that it was that same shape. We just have a different value for what that opening is. Okay, so some random just checking that you understood. How could you also label the angle GHL? Well, as long as I kept the vertex the same, I could flip it. We might be able to call it angle H by that vertex, but again, only if it's the only angle. Are these two things the same angle? I can immediately say no by checking that their vertex isn't the same. Whereas here, ABC and CBA, yes, the vertex is the same. They've just switched the order of which way I read it. That is the same angle. Classifying angles. This is something from junior high / elementary school, so I really don't want to waste your time with this, but if for some reason you don't know these, you need to. Okay, a right angle is at perfect 90 degrees. Acute is when it is less than 90. Obtuse is anything between 90 and up to 180, because once it hits 180 and it's a straight line, we don't call that obtuse anymore. We actually think we just call that a straight angle. There may be other names for that as well. Okay, but that's just generally what we should know. So if I say, hey, this angle is 62 degrees, or this angle is 91 degrees, I should be able to classify that as acute or obtuse. Now, small nitpick that I'm noticing, because what notation is important. So when I say angle A, I'm referring to the physical object on the sheet of paper. But when they put the M in front of it, the measure of angle A, that is where we're talking about the value. So this is sort of like when I have a segment AB, talks about the object, but the AB as the distance is like, okay, but how long is that? It's 5. Okay, I can have the angle A refers to this angle called A, but if I say the measure of angle A, now I want to know that that is equal to like 48 degrees or whatever. So why I just noticed that is this is a degree amount. That is not the right way to write this. This should say measure of, if we're talking about the value. Otherwise, I'm saying the ink on the sheet of paper is the number 62. No. The amount of that ink on the sheet of paper is opened 62 degrees. Okay, so small clarification. So again, we just have two quick examples of like how this will work as a math problem where you have to set something up and solve. Find the measure of BHC and the measure of angle DJE if, oh my gosh, all these words. Basically what I just see is this congruent sign. Congruent sign means things are the same size and shape as each other, so I'm likely going to be able to set their values or their measures equal. BHC, does it give me information about that specifically? Yes, that one is 4x plus 5. DJE, yes, so they weren't trying to be sneaky, like give me half of it or anything weird like that, so I always check what's going on with that. We solved this, right? Subtract 3x is 1x, subtract 5 is 25. Here is the value of x. Do they want x? Let's find out. It says find the measure of this and find the measure of that. So they don't care what x is. So if this is a test question and I just wrote 25, went woohoo! Like, you did not answer that question. So the measure of those angles is when I plug 25 in. 25 times 4 is what, 100? Plus 5 is 105 degrees. The other one, because they're congruent, I know should also be the same, but you could check if you wanted to. 25 times 3 is 75, 85, 95, 105. Yes, okay, so both of those should work. Let's just see what this last one says, if there's anything specific. I'll just basically work out one of these because it's kind of just doing the same problem twice. It mentions that KJ and KM are opposite rays, so they are confirming that K to J and K to M definitely make a straight line, and that's a 180 degree total, and that they're not just kind of looking like it. They are confirming for you that they are. This word bisect, anytime you see bisect, it means something's cut in half. So I'm bisecting a segment, I'm bisecting an angle, it means cut that in half. So it says KN, so the ray, so the dot from K going through N is cutting in half JKL. So the angle from J to K to L has been cut in half. And so sometimes with segments, we do the little ticky mark. With angles, we'll tend to draw like a little whoosh and a little whoosh. If there was like another angle, let's say like this one, we might say single whoosh, and then we would call this like double whoosh, double whoosh. That's kind of how we labeled it, right? It's like a rectangle, it's like these are the same, these are the same. We do the little curl mark for an angle. So, what does it say about those things? It says JKN, so JKN, so just this part is 8x minus 13. Then it says NKL, NKL is 6x plus 11. Now, it is important to label these things because a lot of times students go, oh, bisect means cut in half, they're probably the same. Let me just set them equal and solve. Sometimes that is 100% correct. In fact, if I could write this correctly, 8x minus 13 is equal to 6x plus 11. Yes, I can solve that, find x, and then plug it in for the one I want to know. But if they're being more sneaky pre-AP geometry, they might have said this. They might have said, you know what? This one is 6x plus 11, and this one is 8x plus 13. Well, those are not the same as each other. Now, if it did still tell me that this bisected, what I would have to do is say, sneaky, 6x plus 11 plus another perfect copy of 6x plus 11 equals the whole thing, like 8x minus 13. Okay, and like I said, I'm not going to work those out, but that's just the setups that I want you to watch super carefully. Are they giving me two things that are equal? Or are they telling me what half of it is, and I know that these are the same, so I can duplicate it equal to the whole distance. So it's kind of like these two parts are matching, or the two smaller parts add up to the whole thing. So just watch that. The answer key to these notes do have these problems perfectly worked out to the end if you're interested in seeing the final answers. Otherwise, get on to the homework and have a good one. Actually, I ended the video without acknowledging what the homework was, right? So it's on your calendar, but here's the textbook pages. And if you're watching this video on the correct day, Tuesday, this Wednesday 9-9 quiz is literally tomorrow. So the quiz is tomorrow, and it is over just the chapter 1 stuff. So it's not over any of the chapter 9, like reflecting, rotating things. It's just the chapter 1. And I would recommend looking at all of your warm-ups and making sure that you can do all of that. All right, now you can go. Bye.